Paul, help me. I do not know what I'm doing.
Yeah, dude. What's the problem?
Alright, it's impulse momentum. So the moment of inertia of the pulley is 0.4 slugs feet squared. The coefficient of kinetic friction between the 5-pound weight and the horizontal surface is mu equals 0.2. Determine the velocity of the 2-pound block and the angular velocity of the pulley when t equals 5 seconds. The system starts from rest. So what is the velocity of the 2-pound block if the mass of the pulley is neglected?
Okay, well, the start of this problem is pretty simple. Here what you do is you take the impulse momentum of these two diagrams, which is going to be the sum of these forces, which is mg minus t equals the mass times change in velocity. And we know some of these values, so we can get integral 2 minus tension equals 2 over 32.2 times v final minus v initial, which equals 0. We know that we want the velocity at 5 seconds, so we take the integral from 0 to 5, and when we do the calculus and the algebra, we end up getting v equals 32.2 times t minus 1. V in, for this v, we get t equals 12 over 7, and then we can plug that t back into this t and get v equals 23 feet per second. Fortunately, I don't know what the next part of this is, so I'm going to have my friend Andy explain the next part.
So for the second part, you're going to use the impulse momentum equation. We take omega 2 to be v2 over r, and then we take the moment about the origin. So your t1 is going to be positive times 0.5, and your t2 is going to be negative times 0.5. And then we take the integral from 0 to 5 seconds because that's our time. And then from there, we plug in everything, and our v1 is equal to v2 because they're tied to the same row. So then it's easy when we go back, we're going to plug this equation into our original equation for t2, and then because v1 and v2 are equal, it allows us to solve because we'll have the right number of variables. So we use the equation from above, and we plug in our t2 value that we got just now, and so when we plug that all in, we now have to solve for t1. And then we take the other equation we did from the first time for this t1, and we'll plug in t1 here. And then now we're only left with v1, but then v1 is also equal to v2, like I had said before, so now there's only one variable. So when you solve for v2, you get 3.243 feet per second, and that would be in the downward direction for t2, which is our 2-pound block. And then omega is equal to your velocity over your radius, and your radius is 0.5 feet. And so then we take that, you get 6.4869 radians per second, and that equals your omega.
Thanks, guys.